go ahead and get the housekeeping done up front for folks as we get set up. I'm Nick Reichart, Technical Product Marketing Manager at Buildkite, and this is our final webinar on the final day of UnblockConf21, and we have a real fun one for you. So I am going to go get off this camera and mic and give my voice a rest and hand things over to Mike, who is going to be your Buildkite host for this session. Take it away.
Awesome. Thanks, Nick. So hi, everyone. Mike again. Maybe I saw you in the last session, maybe not, but if not, thank you for joining. We're going to get started now. We're just past the hour. So this session is called Autoscaling Bazel Remote Builds and EC2 Mac with Buildkite, Flare and Nodeless Kubernetes. So we've got a lot to cram into the time. We've got a selection of hosts here joining us from Flare, build and Elotl. I'm going to let everyone introduce themselves, actually, because they'll do a way better job than me. But before I do, just some housekeeping. So we've got you all muted during the webinar. But if you have any questions, please throw them in the Q&A chat box. And as with all the other sessions, we'll be sending out links to the recording once it's complete. So if you need to rewatch it or share it with friends or whatever you do with them, then you can absolutely do that. So I'm going to hand it off to our presenters now. So maybe Zach, do you want to take it away?
Sure. Hey, folks. I'm Zach. I am co-founder and CEO here at Flare Build. And so we're working on mostly providing SaaS products in the Bazel space, as well as a little bit of consulting for folks working to build at scale. I'm really excited to be working with Buildkite. It's a great product. A lot of our customers love it. Yeah, we're super thrilled. Also presenting with me is Madhuri from Elotl. And so Madhuri, if you want to give a quick intro for yourself as well.
Sure, yeah. Thanks so much, y'all, for giving us the opportunity to talk about our stack. I'm Madhuri. I'm founder, CEO of Elotl, makers of Nodeless Kubernetes. We commoditize compute for Kubernetes. So think about it as you get a single Kubernetes control plane, and under the covers, Mac Metal or ARM or any compute shape and form from any cloud provider will automatically be consumed. CI is a very exciting space for us to provide value to via Nodeless Kubernetes platform. And we have seen a huge uptake in Buildkite being the preferred CI provider amongst our customers. So super excited to get this demo going and share with you guys how we are bringing value of Buildkite on Kubernetes platform on public cloud. Thanks, Nick and Meg and everyone else, Mike at Buildkite, for giving us this opportunity to share our work. I'll hand it over back to Flare with Tatiana.
Oh yeah, thank you. I didn't plan to speak today. It's mostly going to be Zach. But yeah, I'm co-founder and CTO here. So if you have like any questions, I might be useful answering them in chat while Zach is talking.
Great, thanks. Yeah, I'm gonna go ahead and see if I can get the screen share going, and we'll run through this little chat here. Just give me 1 sec. Cool. Cool. So yeah, obviously the title of our talk here is Autoscaling Bazel Remote Builds and EC2 Mac with Buildkite, Flare, and Nodeless Kubernetes. A lot of stuff to kind of cram in there, of course. So we'll unpack that a bit here. But yeah, I mean, the key, I think the key element here is, I think at this conference we've heard, already a lot of great talks about folks getting excellent use out of the Mac instances from Amazon, managing some of that stuff using the typical Amazon tooling. And really the focus of this workshop is really just sort of illuminating a little bit about how we've approached the problem that we still see with some of the rough edges that still exist on some of these products. And so what we've kind of done to sort of tame a lot of the chaos that's going on here. Because when we add Bazel and remote execution, which we'll unpack, we add that into the mix, there's still quite a lot of stuff left to solve. And that's kind of what we've been working hard on the last year or so here. So a little bit more background info on Flare for folks that aren't familiar. So like I said, we're working primarily with Bazel. And so Bazel is an excellent build tool. I'll explain a little bit more about that as well in the coming slides for folks that aren't up to speed. We're part of Google's Bazel Experts program. We've been working with a lot of customers for quite a few years now to sort of migrate their builds over to build with Bazel, and then eventually roll out some of the more powerful features that Bazel has to allow you to execute builds across a big cluster, things like that. And so that's just a little bit more of the background on Flare. So like I said, I mean, the AWS Mac Metal instances are great. We're super excited to see this product hit the market. No more closets full of Mac minis. We've got standard DevSecOps tooling back on AWS, where the security teams for folks building at scale are really going to want this stuff. Obviously, Oliver had a great talk covering all of this in depth. You should absolutely go see it if you haven't. And I think there's a few other talks as well on that stuff, so definitely check those out. Going to try to avoid rehashing any of that stuff because I know you've already seen it. We're going to talk a little bit more about how we sort of take in some of that stuff to the next level here. So like I said, these instances are great, but there's some issues still, right? So sort of first and foremost, these instances are expensive. So even with discounts, they still come in at quite a bit more than the cost of just outright buying yourself a Mac Mini. So here we can see, okay, here's the yearly cost of a single instance versus just going out and buying one. Now, obviously, bulk discounts can help a little bit here, but really not enough. So really, the pricing is a big challenge here. So that's sort of one of the biggest blockers for a lot of folks that are evaluating this stuff actually is just, the pricing. So that's sort of one area where maybe there's something we can do here, right? Another challenge is, I think that the thing that comes to mind when we think about, okay, these are expensive, let's turn them off, right? So while it is definitely possible to do some, auto scaling with these Macs, the challenge is that there's a sort of a big limitation here because of the licensing model. So what that really is, if you read the fine print, is a 24-hour minimum allocation. So really, it's not really auto scaling. Like, it's not really that elastic, right? Like if I turn on 10 nodes, there's a chance that those might hang around for another 23 hours after I needed them, if I only needed those 10 nodes for an hour to get the quick burst done, right? So the net result of this is that using standard auto scaling that we get from Amazon, it's really, the net result is just underutilized instances, right? The existing autoscalers are really meant for the Linux workloads. They're not really a good fit here. So this CPU chart here is from a production instance of a CI machine. One of these Mac instances running a Buildkite agent, actually. And so we can see that there's quite a few kind of dead zones here where this agent wasn't active doing anything. Those jobs are being scheduled elsewhere. So this is sort of one of the big challenges right now. Even if you do have an auto scaling group hooked up, you'll often find that, unfortunately, these instances are not going to be completely utilized because of this limitation. So this is sort of a big opportunity that we see to maybe level up and solve this by using some of the more advanced tooling that we're going to talk about here. So another challenge is management is definitely easier, but it's not easy. As anyone who's been working with Amazon for a while will know, the smallest change to AMIs can take hours to bake and roll out to large instance groups. And configuring the auto scaling for these CI workloads is still fairly complex, even when we have AWS primitives and tooling like Terraform to assist with that. So, you've got to kind of create just the right Terraform templates, get that stuff all launched. And then there's a bit of manual work, which we'll touch on as well, that you're still going to have to do here, even with all this stuff wired up. So still a big challenge here. So to sort of recap on these problems, configuration management is still a challenge. Auto-scaled instances are underutilized and they're very expensive. And what about Bazel, right? So if we're using Bazel to run maybe our iOS or our macOS builds across a cluster of Buildkite agents doing our CI builds on Mac, we still have to deal with providing maybe some shared caching infrastructure and remote build infrastructure for Bazel. So a quick TLDR on exactly what that is. Bazel in a nutshell is Google's open source build system. It's universal, extensible, and fast if the parameters are right. Actually, many folks may not know this, but Bazel actually has great support for iOS and broad adoption, especially among folks in the Mobile Native Foundation. Thanks both to work from Google. They've been using Bazel to build their iOS stuff for quite a long time. And the community also has jumped in and done a lot of great work here. So a lot of the MNF members have done awesome work. And obviously, like I'm sure you've seen some of their talks, so I won't go too deep there. But yeah, so one of the coolest features in Bazel is remote build execution. And so by this, what we mean is that the open source Bazel client is actually able to orchestrate build and test actions to run either locally, so that could be on a developer machine or a CI agent, or remotely, which means in a separate remote compute cluster, or not at all, of course, where cached items are just simply not rebuilt or just downloaded. So to make use of distributed builds, of course, we need a server that implements a few remote API protocols that ship with Bazel. So of course, Flare.build's offerings directly sort of slot in here. But one of the big challenges here is that Bazel distributed builds for Mac, if you're building iOS apps, for example, you still need to provide Mac infrastructure on which to run those remote builds. Obviously, the Apple toolchains must run on Apple hardware. So, this, if you think about this, like we've just done all this great work of solving autoscaling the Buildkite infrastructure. Well, now we've got this separate problem of figuring out what to do with our Bazel remote executors, right? So that's sort of another challenge that we need to go back and kind of figure out here. So, so some solutions to these problems that we outlined before. So the first problem of configuration and management still being a challenge. Well, what if we could use Kubernetes and cloud native best practices to go ahead and solve the problems here, right? Like a lot of the issues that people are still seeing with these Macs are really solved by Kubernetes already. So no need to reinvent the wheel here. Also, when it comes to the problem of auto-scaled instances being underutilized and expensive, well, what we've done here is actually rolled out a way to use dual use agents to greatly increase the utilization and sort of fill in those dead zones in that CPU chart we saw. And so this allows us to accept both Buildkite jobs and Bazel remote actions on actually on the same machine, and really ramp up the amount of usage we're actually getting out of that machine. And also, because we've rolled out the dual use agents, we don't need to support additional infrastructure for Bazel remote builds when we're working with remote execution for maybe our Mac CI pipeline, right? So sort of to recap the solutions here. So obviously Buildkite for iOS, it's great, we love it. Buildkite on top of the new AWS Mac Metal instances, even better, super exciting. Using Kubernetes to manage the Buildkite agents running on Mac Metal, that's really awesome. But absolute total galaxy brain here is using Kubernetes to manage both Buildkite agents and the Bazel remote execution agents running across these AWS clusters, and that's where we're at today. And so at this point, I'll go ahead and hand it over to Madhuri to jump in and sort of dive a little deeper into how they're making use of Kubernetes to manage some of this stuff for us.
Yeah, thanks so much, Zach. This was super interesting to see that you guys have identified the holes in the underutilized Mac Metals, and co-locating the Bazel builds on it is a fantastic idea. So from Kubernetes point of view, one of the frequently asked questions that people ask us is that, hey, we have these Mac Metal instances that AWS has made available to us. What is the difference between manually managing Mac Metal instances versus using Kubernetes to do it? Like Zach mentioned earlier, a lot of the things that you would have to do if you want to manually manage Mac Metal instances are problems that have been solved in the Kubernetes ecosystem already, and there are best practices in place, and it gives you knobs to fine-tune the settings that you would want to get the most out of your Buildkite agents on the Mac Metals. And also, no one has ever been fired for picking Kubernetes. So these are the two overwhelming themes. But digging down into details, let's get into the details of what are the key differences between manually managing Mac Metals versus Kubernetes along 5 5 axes. So the first one is graceful termination. So by graceful termination, what people mean is that, hey, we want the Buildkite agent to be gracefully terminated when there are build jobs that are running on the Buildkite agent on this Mac Metal, and we don't want any builds to fail as part of graceful termination. And the second component is graceful termination of the Mac Metal itself. The second axis is Buildkite agent configuration. So we want to be mindful of how easy is it to create, configure, and maintain Buildkite agent configuration at creation time, maintenance time, configuration time as well. So we'll explore a bit deeper into the Buildkite agent configuration ease of use. The third axis is autoscaling. We'll split autoscaling into 2 parts. We want to see how easy it is to autoscale Buildkite agents based on the pending build jobs in each queue, and also autoscaling Mac Metal instances as well. And the fourth axis is instance recycling. We want to see how easy it is to recycle existing instances. And the fifth axis is how do we deal with bad nodes that might come up as part of booting up a brand new Mac Metal instance, or if a reboot fails. So let's get into the graceful termination axis first. So what we want to see is for Buildkite agent graceful termination, if we want to do it manually, you can actually go and manually flush the queue on a given agent and shut down the Buildkite agent, or you can create, configure, and maintain EC2 autoscaling lifecycle hooks for graceful termination. With Kubernetes, you get that out of the box because Kubernetes will actually, if Buildkite agent pod is terminated, it'll wait for the agent to shut down gracefully. It sends a SIG term to the pod, and the agent will complete the existing builds in progress in flight and shut down the agent gracefully. So it comes out of the box. Next, we look at graceful termination of the Mac Metal instance itself. In the manual mode, you can go and click terminate on your EC2 console for Mac Metal instance, or you can again create, configure, and maintain EC2 autoscaling lifecycle hooks for terminating the Mac Metal instance. With Kubernetes, it's automated. It comes out of the box. Nodeless Kubernetes will make sure that when an instance is recycled, it'll cordon off the instance so that no new pods or Kubernetes workloads are scheduled onto that instance, and the instance is automatically terminated gracefully. So there is nothing that you need to do, create, configure, or maintain if you use Kubernetes. The next axis that we are going to look at is Buildkite agent configuration. So let's look at the config location. For manual, you'll have to bake your Buildkite agent configuration into the AMI, and for Kubernetes, it's actually passed to the agent via Kubernetes best practices using secrets and config maps. So these are constructs that are available out of the box in Kubernetes environment. For example, here is a customer anecdote. This is a large deployment of Buildkite agent on Mac Metal that one of our customers has in production. So the customer needed to periodically update Buildkite queue tag for their builds. So if the customer were using a manual agent config management, they would have had to start a reference node, connect to that node, and update Buildkite agent configuration on that node, and create a new AMI from that node, wait for the AMI to be available, and once it is ready, they'll have to restart all the nodes with the new AMI. In addition to the effort involved in doing these manual tasks, there is also the time cost, which is going to be a couple of hours, because starting a new Mac Metal instance can take take up to 10 minutes, and generating the AMI could take up to 15 minutes. So depending on the number of nodes you have in your fleet, this could easily add up to a couple of hours. With Kubernetes, you simply have to run 2 kubectl commands. The first command is to update the Kubernetes secret and config map, which has the Buildkite agent config. And the second kubectl command is to roll out the Buildkite deployment, and Kubernetes will automatically pick up the latest update to the secret and config map and update your Buildkite agents with the new config update. So the time taken to execute and apply these 2 commands to your Buildkite agents would be less than 5 minutes. So this is an actual real-world example of what are the maintenance tasks that are involved in maintaining your Buildkite agent config, and what's the different effort and timelines involved in doing it manually versus Kubernetes. Next, let's go ahead and talk about autoscaling. Let's talk about Buildkite agent autoscaling. So in the manual mode, Buildkite agent autoscaling and Mac Metal autoscaling are tightly coupled. So you would need to set up an EC2 autoscaling group and set up Buildkite metrics exporter to CloudWatch using perhaps a Lambda function, and define the autoscaling group scaling policy using the exported metrics. And also you'll have to maintain, monitor, and update these policies based on the changes in the workload patterns that you would see. In the Kubernetes environment, the Buildkite agent autoscaling is decoupled from Mac Metal autoscaling by design, which allows you to gives you a lot more power as the end user. And I'll get to an example shortly with that. So the Buildkite agents are autoscaled using a Kubernetes horizontal pod autoscaler, which is again a native Kubernetes construct. And and we'll show you how that works in the demo shortly. So you can set up, it gives you the power to set up different node pools for different build queues, and you can do that with the push of a button, etc. So it enables you to be a more power user of setting your autoscaling, the autoscaling policies that you would want, rather than have the Buildkite agent autoscaling be super tightly coupled to the Mac Metal autoscaling. With respect to autoscaling of Mac Metal, the compute autoscaler has built-in smarts to be aware of the characteristics of the compute, like cost, startup time, the 24-hour billing cycle, etc. And it makes smart decisions for scaling for you. For example, it might actually keep an agent on. If you've already paid for 24 hours for the agent, it will reuse the agent for near-term bills within the 24-hour cycle instead of terminating the agents. So these are the two key differences in autoscaling Buildkite agents and autoscaling Mac Metals in the manual versus Kubernetes world. Next, let's go ahead and look at instance recycling. Again, this is a customer anecdote from a production customer that's running iOS build and test workloads using Buildkite agent on Mac Metal. The customer needed to reboot the Mac Metal instances periodically because of issues with the nodes or issues with the leftover state in the builds and stuff like that. In the manual mode, they would have had to create, configure, maintain instance refresh option in EC2 autoscaling group, so which is not straightforward to do. There are issues with graceful termination, like we talked about earlier, and lack of garbage collection on the Mac Metal dedicated hosts that makes this kind of like a tedious and overwhelming process to do manually. With Kubernetes, you can configure a knob, and with the push of a button, you can apply your reboot policies for whatever reason you would want to reboot your Mac Metals periodically. Next, let us talk about bad instances. Again, a customer anecdote in September of this year for this production customer that's running iOS build and test on Mac Metal instances. 5 to 10% of the provisioned Mac Metal nodes were faulty, where faulty is defined as the node never comes up online despite being marked as running. So in this case, in the manual mode, the operator would have had to manually detect and remove faulty nodes before Buildkite agent tried to unsuccessfully run on it and would have to triage, hey, is this build failure or startup failure because of my Buildkite agent configuration, or is it a hardware issue? With Kubernetes, bad instance detection is automated. The node isn't even made available as a suitable node to run Kubernetes workloads if it is not healthy. So it's not even going to appear on the list of suitable nodes for running your Buildkite agent pods. So given these differences between manual and Kubernetes, the TLDR is that, yes, it is feasible to do to manage your fleet of Mac Metal instances manually, but it's a question of the effort and time involved. Do you want to put in the time and effort to do it manually, and do you have the team size to do it manually, versus do you want to pick a standard platform like Kubernetes that gives the best practices out of the box for you? Given these differences, we want to talk about how Flare structured the architecture of running a build scaler to scale the Buildkite agent and Flare Bazel agent pods based on pending jobs in the Buildkite queue. And these pods are then scheduled onto Kubernetes platform, where Nodeless Kubernetes scales AWS Mac Metals based on the pending pods, pending Buildkite agent and Flare build agent pods. And Kubernetes takes care of dynamic configuration, graceful termination, health checks, and bad instance management, and all of the good stuff that we talked about earlier. And eventually the Buildkite agent pod and the Flare Bazel agent pod both are co-located on a Mac Metal, and they run as a single pod on the Mac Metal instance. So let's go ahead and look at some stats from the production deployment of Buildscaler and Nodeless Kubernetes. So this is a screen grab of a CloudWatch metrics dashboard of how your running build jobs are impacting your total Buildkite agent count and the idle agent count. So you see that the Buildkite agent count is increasing and decreasing in lockstep with the running jobs. So if there are more pending jobs that are in your Buildkite pipeline, the number of Buildkite agent pods is scaled up automatically right away. And if the number of build jobs goes down, the number of Buildkite agent pods also scales down. So there isn't much of a delay in the reaction time. So the scaling up and scaling down of the Buildkite agent and Flare Bazel agent pods are happening in lockstep. Next, let's look at the Cost Explorer dashboard from AWS for scaling Mac Metal instances based on pending Buildkite agent and Flare Bazel agent pods. So what we see here is that we see that the cost of your Mac Metal instances is increasing and decreasing, and this again happens in lockstep with the increase and decrease in the number of Buildkite agent pods, which happens in lockstep with the increase and decrease of pending builds in your Buildkite agent in your Buildkite queue. So you're paying exactly what you need rather than what you think you would need for peak utilization or peak builds that might be coming in only once in a while. Let's go ahead and see how Flare has set up this entire environment inside their AWS account. So we will start with the number of nodes in the Kubernetes cluster of instance type Mac Metal. So we have one Mac Metal instance running, and we have one Mac Autoscaler. This is the compute autoscaler from Nodeless Kubernetes, which runs as a Kubernetes deployment inside the environment. So this autoscaler is connected to external metrics deployment, which actually collects the metrics for pending builds in the Buildkite agent queue and connects these metrics to the horizontal pod autoscaler, which is the build scaler. So the horizontal pod autoscaler has a couple of parameters configured in it. The horizontal pod autoscaler is looking for Buildkite busy agent percentage. So how many agents are busy in the existing fleet of Buildkite agents. So if it is once it hits 90%, we would want to scale up the number of Buildkite agents from 1 pod up to 3 pods. So from 1 to 3 Buildkite agent pods. Currently, we only have 1 Buildkite agent pod running. So let's watch the build scaler in action. If we go and create a new build, we would trigger the threshold of 90% of busy agent percentage. So this should, in the bottom right window, you see that there is a new Buildkite agent that is in pending state. So the number of pods for Buildkite agent has been pumped up from 1 to 2. This is a decision made by the build scaler horizontal pod autoscaler. And once the number of pods have been pumped up from 1 to 2, the compute autoscaler reacts to it, and it is in the bottom left window, you see that a brand new Mac Metal instance has been spun up, and the new Buildkite agent would be dispatched over to this compute node. So we can go ahead and look at the logs for what is happening on this brand new Buildkite agent. And I'll let Zach explain what's going on the Flare build end of things.
Cool. Yeah, so just looking at the demo video here, so we can see in the output here, we see that there were a number of remote cache hits. These are actions that were cached in Bazel, but we actually see there was 11 actions run remotely. So in this case, this is a pipeline that's just building Bazel for macOS. It's building against the remote workers running on the same cluster that our CI infrastructure is running on here. And we can also see we extracted a little bit of information about the build. So this is tapping into some of the metadata that comes out of Bazel. So you can see here we actually have a nice little UI presented for what actually went on during this build. So this is obviously a URL we could share to anyone on our team, which is pretty cool. And we can sort of understand what happened, see some build logs, see some parameters from the build. And actually right here, right in the CI window, you can see we annotated. So we saw the success case before, now we see actually some failures. So these were Bazel invocation errors that actually happened in this build we're looking at. So you can see we actually extracted the error, put it right here in this annotation for sort of easier debugging by developers. So in this case, this build failed because this was a build that ran when there were no macOS workers available. And so once again, you can see here in the demo, we click the failure link, we can dive into this Bazel invocation and start to understand what actually went wrong here. And interestingly, we can actually see that we actually extracted some pretty interesting info. So here we extracted the error that occurred there. And so now if we drill into this error, we can see that it's not the best looking error message we see here, but basically this is the error message that came out of Bazel, and we can actually create a solution for this error message so that when other folks on our team get this error, they can automatically be pushed the solution to the error without having to go try to understand why their build is failing. So this allows DevX managers, engineering leaders to sort of curate errors and solutions for their users. And so now back on the demo, we can see the job finished. And we can see that the pods are terminating here. And so we're actually, shutting down these pods. Now, unfortunately, because of the 24-hour limitation, we're not actually going to see the Mac autoscaler turn off this instance, but that's something that could happen in the future, given enough time here. So yeah, that's it for the demo. That's really, pretty much all we've got here. We do have a little bit of time left to talk about two things. So the first would be future roadmap. So there's still a few items that we haven't gotten to yet that we're really excited to continue working on. And so the first of these would be Bazel specific optimizations. So there's a number of things we're pretty excited to do to continue to speed up the power of Bazel and take advantage of the fact we're actually co-locating these pods on the same nodes. So one example of this would be to intelligently actually share the worker outputs directly with the CI agent running also on the same nodes. And so I think there's some kind of interesting work we can do there to short circuit network calls and things like that if there's already some of these blobs locally because of other work that was done there by the co-located remote executor. So that's something we're actively sort of looking into at the moment. Also, a few other items on the build scaler front. Of course, we're trying to get a little bit more granular in our scaling. So currently, of course, you've seen we're scaling based on mostly on the Buildkite queue as our main metric, but of course, we're working on some other formulas by which you might scale, such as the pending action queue depth over some like 12 or 24-hour period, something like that, to allow us to sort of respond to a few other signals and scale the infrastructure with a little bit more control. And then, of course, on the Nodeless side, Madhuri, if you want to jump back in here, I know you have some other thoughts.
Yes, for sure. Yeah. So on the Nodeless side, Nodeless automatically consumes any compute option that's available for you on the cloud provider. So we do expect AWS to launch M1 instance support or VM shapes for Mac. So as and when these newer, better instance types are made available to market by AWS, Nodeless will automatically consume them. So you don't have to worry about, hey, AWS launched M1 support at reInvent, and I created all these auto-scaling groups for my Mac Metal, and how do I consume the newer, better instance shapes that are available?
Cool. Yeah, so that's it. We definitely have some time for Q&A and stuff here now. So I'm not sure if any questions came in at all, but definitely we'd love to take the rest of the time here to chat both about some of the challenges of deploying Kubernetes on top of all this stuff, because there's a lot of great work that Madhuri and her team have done there. And then obviously on the Bazel side of things, there's tons of other moving parts. So we're happy to sort of dive into any questions that folks have on any of that stuff.
Oh, sorry, go ahead.
Hey, Matthew, thanks for asking if the stack works with AWS Graviton-based executors, and the answer is yes.
Okay, any more? I wonder if we have any more questions. Now's the time to ask them, guys.
I feel we should let everyone talk if you want to have a discussion.
Oh, we have some questions coming in. Yeah. Is there an open source repo for the tech stack?
Unfortunately, no, there is not. There are some, obviously some components, of course. Kubernetes is open source. Bazel, of course, also is. But yeah, there's a lot of the stuff here is sort of proprietary in-house stuff. This is something that on our side, I'll let Madhuri, of course, jump in here too, but on our side, this is something we're actively thinking about how we can sort of start to open source more components. So stay tuned on that front. But Madhuri, I don't know if you have any other comments there.
Yes, for sure. So vanilla Kubernetes doesn't yet support macOS compute shapes, but we are working on open sourcing components of our Mac Kubernetes stack as well. So we'll keep you all updated on that.
Great. Yeah. And so I think that sort of is a great segue into the Docker image question, which is a very fair and obvious question. So maybe Madhuri, go ahead and answer that one too.
Yes. So Yuki, so I'm curious if you mean Docker image for the Buildkite agent, or what other Docker image are you talking about? So Buildkite agent, when we provision dedicated hosts, it is one of the available OSs that are available on the via AWS AMI options that we provision. So it's nothing that's different, and we would be running the pod for the pod manifest is the pod manifest for for Buildkite agent, it includes the Flare build as well, Flare build agent as well. So maybe I can take this offline and share with you the manifest that we use, or we can follow up with an email with the manifest that we use. Does that sound reasonable, Yuki?
Yeah, I mean, I think to add a little more color there. I mean, obviously, I think when we start talking about Kubernetes, everyone's just like, okay, so you must be running Docker images or some sort of containers, right? So maybe we can unpack that a little bit more, like how the macOS hosts aren't actually running Docker at all.
Yes, so the macOS hosts are running a container engine, and it is exposed to the Kubernetes control plane as a Kubernetes worker node. So it's not your run-of-the-mill worker node from Kubernetes that you can get off the shelf from EKS, because there's some amount of work needed to make sure that the Mac Metal instance dedicated host, you're pretty much getting a bare metal instance. It's made available to the Kubernetes cluster as a regular Kubernetes worker node, and that's the tech involved in Nodeless Kubernetes.
Cool. There's another question here. Madhuri, sounds like a good fit for you. So I don't know if everyone can see these, or not. I guess maybe we should be reading them. So if you want to go ahead and read that one, the permissions stuff, and then maybe
yes. So Lawrence Stan is asking if in his setup with the in his setup he assigns AWS permissions per queue, which is helped by using AWS accounts as boundaries. How to solve this with the K8s model, where for the benefit of scale, a single cluster runs in a central account? That's a really good question. So in the Nodeless Kubernetes world, each Buildkite agent pod, which might include the Flare build agent, is going to be running on its own bespoke Mac Metal node. So you have that delineation of each Buildkite agent running on its own Mac Metal by itself. So the boundaries are pretty tight out there. So if you want more finer grained boundaries than that, probably if it would be the same as provisioning two separate Mac Metal instances within the same AWS account per queue. But I think what you're trying to do with having a separate AWS account per queue, you can achieve the same thing by running it on Kubernetes, because you get the Mac Metal to Mac Metal separation boundary between your separate queue Buildkite agents. Does that make sense, Lawrence?
Yeah, I think one other note to add on that front also would just be that once you're in Kubernetes, of course you're open to using like role-based access control and namespacing and permissions and all that stuff too. So I think there's probably a number of different configurations you can go after, just using whatever sort of best practices that your cloud native teams are already using.
That is true as well. Yeah. So you can have the namespace level isolation, and you can also have the runtime compute isolation as well via Kubernetes. And it's the hooks that Kubernetes allows. Again, it's not something that we built specifically. It's what you get out of the box by using Kubernetes. Thanks, Zach, for pointing that out.
Sure. And so yeah, so Matthew asks, is integration of Bazel test results with the Buildkite test analytics on the Flare roadmap? Yeah, I think we're definitely happy to integrate as much as makes sense here. Like we saw in the brief demo, of course, we're already sort of making use of the annotator to get some stuff right into the Buildkite UI. So yeah, happy to kind of continue down whatever integration roads make sense. So yeah, definitely something we'll keep an eye on.
We'll take it. Well, right on. Thanks so much, everybody. That is a fantastic way to end a day of webinars. Thanks to our speakers, Zach, Madhuri, Tatiana, everyone else who's presented today, Mike, Mel setting all this up, and every one of you watching. That about wraps things up. Is there anything before we sign off that folks would like to promote or send folks to?
A big shout out to Buildkite for building the best CI platform of 2021.
And also hosting this crazy event, right? It's been like a short notice and a lot of participants in different time zones. Yeah, very impressive.
Yeah, great. Thanks a lot, everyone. Yeah, definitely. Yeah, super stoked about Buildkite. It's awesome to see such great products really, yeah, hitting the market. And yeah, from the Bazel perspective, if you're interested in learning more about Bazel, feel free to reach out to us at Flare.build. You can go to the Bazel Build website, check out the experts page. There's plenty of folks on there you can get in touch with to sort of figure out a little bit more about the build tool, if it's right for you and your team. And also BazelCon, I think has another day maybe. So if you're really interested,
Yeah,
maybe you can
tomorrow.
kind of sneak in tomorrow and find some additional talks and all this stuff. So yeah, that's really it. Thanks a lot, everyone.
Thank you.
Excellent. Take care, everybody.
Great.
Thanks,
See ya.
Nick.
Bye.
Bye.
Made it.